In this video, I'm going to show you how to find the mean value of a function. So if we have this general function here, f of x, and we're trying to find the mean value of this function between the range of a and b, then you'd expect the mean value to be somewhere between the upper value for b and the lower value for a. You'd expect the mean to be somewhere in here. So we'll have a little line here, and we'll say that this is our mean value, which we'll call m hat. So is this a value m hat which we're trying to find? So we know that the mean average m hat is equal to the total divided by the sample size. And because m hat is a y value, what we need is the total of all the infinite y values between a and b. But that's exactly what integration gives us. It gives us the sum of all the y values within that range. So the total will be the integral between a to b of f of x with respect to x. And then this will be divided by the sample size, where the number of values you've got between b and a is the difference between b and a. This will be divided by b minus a. And we can write this a little bit simpler, where the mean value, m hat, will be 1 over b minus a multiplied by the integral of a to b of f of x with respect to x. So this is the formula to work out the mean value of a function. Okay, so for example 1, we've been asked to work out the mean value of this function between x equals 0 and 3. So m hat will be equal to 1, so 3 take away 0, times the integral of the limits between 0 to 3 of 3x squared plus 6x minus 2, integrated with respect to x. Well, 1 over 3 minus 0 is 1/3, and we can integrate this, and we get add 1 to this power, then divide by the new power, and that becomes x cubed. Then we add 1 to this power of 1, so it becomes 2. Divide this by 2, and that becomes 3x squared. And then we'll add an x to this constant term, so minus 2x. And this is between 0 to 3. So now we'll substitute in our limits. We get 1/3 of 3 cubed, so 27, plus 3 squared, which is 9, times that by 3, so another 27, minus 2 lots of 3, and then take away when we substitute in the 0. But when we substitute in the 0, all of these become 0. So I'll take away the 0. So our bracket becomes 48, and 1/3 of 48 gives us a mean value of 16. So the average y value of this function between x equals 0 and 3 is going to be 16. Okay, let's try example 2. Okay, so for example 2, we've been asked to work out the mean value of this function within the interval of 0 to 2. So we're saying that m hat will be 1 over b minus a, so 2 minus 0, times the integral between 0 to 2 of 2x minus 1 to the 4, integrated with respect to x. So to evaluate this, I'm going to use a reverse chain rule. So we'll say let y equal 2x minus 1 to the 5. We'll differentiate this. So dy by dx will be 5 lots of 2x minus 1 to the 4. Then we'll multiply this by the derivative of the inner function. So we'll times it by 2. And this is 10 lots of 2x minus 1 to the 4. So to scale this derivative, we need to multiply y by 1/10. So now we have our integral. M hat will be 1 over 2 of 1/10 of 2x minus 1 to the 5 between the limits of 0 to 2. And to make this a bit tidier, I'm going to pull out the 1/10. So the average will be 1/20 times. Now substitute in our limits, so we get 2 times 2 is 4. 4 minus 1 is 3. So 3 to the 5 minus, and when we substitute in 0, we get 0 take away 1. So negative 1 to the 5 is negative 1. So this becomes a plus 1. And 3 to the 5 plus 1 is 244. So M, or the average, will be 244 divided by 20, which is 12.2. So this is our average value for this function within the range of 0 to 2. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.